Today's lesson's on perimeter and area in the coordinate plane. A lot of what we see today is pretty similar to what we learned yesterday. It's just that we have to plot a little bit of it before we do the work. But again, it's mostly distance formula that's our math computation work here, so it should be pretty straightforward. So the learning goal is be able to find perimeter and area given points in the coordinate plane. And then secondly, being able to classify some polygons, and that's actually what we're going to start with in the lesson. So first of all, understanding what a polygon is. A polygon is a closed figure made up of segments. So closed means that there should be no gaps in your shape. It means all of your segments should meet at a point somewhere, and there's no lines through the middle of it. It's just a figure that's closed somehow by some segments. You can see here we have our proper notation for our sides. Those are our segments. Our vertex are notated by points that are capital letters. If we want to label or name a polygon, we write the word polygon and then however many vertices it has, and that'll let us know how many sides it has as well. So if you see 4 letters, it's a quadrilateral. If you see 5, it's a pentagon, and so on. So that kind of leads me to the next point. This is a good thing to have in your notes. This over here, again, most of you know a lot of them, but you might not know maybe a 12-sided figure or maybe a 9 or a 10. So those are a little unfamiliar to us. And then down at the bottom here, don't be confused by this. This simply means anything past 12. Let's say I have a 23-sided figure. For the sake of this class, you're just going to simply call that a 23-gon. We really don't work with stuff like that much in this class. We primarily focus on the stuff, especially in this class, quadrilaterals and triangles. We focus on those quite a bit. The other thing that you may not be familiar with are the terms concave and convex. Now, I don't want to overcomplicate this. A concave figure is one where if it's possible to draw a line, so like you see here, if it's possible to draw a line through your figure and have it continue and cut part of your figure off. In other words, if any one of the segments that form my polygon can be continued and cut through my shape, it's concave. Sometimes kids get confused and they will say things like, well, if I can extend this side over here, it doesn't cut through my shape, so it must be convex. It's if it is possible, not can you draw one. So as you can see, you can't draw one on the left. This polygon is convex. None of those lines cut through your figure. While on the one on the right, you have 2 different lines that will cut through your figure if you extend them. So on example 1, we're classifying the polygons. A, it has 4 sides, so we call it a quadrilateral. You can abbreviate for your notes as well. Notice you can extend either of these 2 lines over here and it will cut through your shape, so it's concave. Okay, on the right here, we have no ability to cut through if we extend all those lines, and we have a 6-sided shape. And so we can see that's a hexagon, and it's convex. Okay, and again, this table is a good one to have in your notes. So as the guided practice roll through in these videos, you can pause and try them, then go ahead and hit play and see if you got them correct. So if we count the sides out on this figure, it's a pentagon, and it's concave. The figure on the right has 7 sides, so it's a heptagon, and it's convex. So some area formulas that we've learned in the past, and you'll get these for the sake of your homework here. You'll want to use these. Pretty familiar. Now, perimeter, you don't necessarily need to memorize a formula. Just remember perimeter is the distance around the outside of a figure. So finding the perimeter with vertices at A, B, and C, what we'll want to do on this one first is go ahead and write these points down, because otherwise we might mistakenly do the distance formula 3 times, and we really don't need to. So at -2, 3, we have point A. At 3, -3, so 3, -3, we have point B. And then at -2, 3, or excuse me, -2, -3, we have point C. So as you can see here, if I draw my figure, I don't need to do the distance formula. So from A to C, I should be able to count. And as you can see, the X's are the same. So I can just look at the Y's and I can see that AC's segment length is 6 units. Likewise for CB, if I just look at those, I have the same Y value. So I just need to look at the change in my X's. And so BC is equal to 5. Now the one I need to worry about here is AB, so I'm going to have to run the distance formula on this one. So from A to B, we'll run the distance formula. So we say -2 minus 3 quantity squared. And then we have 3 minus -3 quantity squared. So -2 minus 3 is -5. We have to square that. -3 minus, or 3 minus -3 is 6. We have to square that. So we get the square root of 25 plus 36. If we add those up, let me punch that in real quick. So we have 25 plus 36, and then we take the square root of that. And we'll keep 2 decimals, so you get approximately, after you add that up and square root, 7.81. And then if I just add 11 to that, that's what I should have for my perimeter. So my perimeter is approximately 18.81 units. Okay, so again, take some time, try these. I'm going to tell you, I'm going to go kind of quick through these and just look at them and see kind of what my distance is. I might just do a couple of them, and then you guys can go back if you want and look at your monitoring progress. But if I let these videos run too long, they won't upload. So I'm just going to do a couple. They should be pretty uniform. Okay. Hey, I need your help. Hey, I need your help. Can you get her so I don't have to pause this? Okay, so on the first one, we have -3, 2. Pardon the noise in the background. On the next one, we have 4, 2. And on the last one, we have 4, -3. So we look and we see that we can count 2 of our segments. We're going to have to run the distance formula on, let's see, what segment is that? So that was D, that was E, this is F. So on DF, we have to run the distance formula. From D to E, we have 7. From E to F, we get 5. And then DF, we're going to run the distance formula on that. So we have the square root of -3 minus 4. We have to square that plus, let's see, 2 minus -3, and we have to square that. So we have -7 squared plus 5 squared. We get 49 plus 25. And so we square it 74. I'll punch that in. 8.60. So then we add 12 to that. So 20.60. Okay, and then the other one I'm going to do, just like I said, for the sake of time, we'll do number 5. So -1, 1 is right here. That's K. 4, 1. L. 2, -2. So 2, -2. That's M. And then -3. So -3, -2. Oh, that's right here. So the nice thing about this quadrilateral you can see is we'll have to do the distance formula, but we don't have to do it more than once because these two are the same, KN and LM. And we can just count the length of KL. So from K to L, we have 5. And N to M, we also have 5. And that means I just need to do the distance formula on Kn, and I'll double it. So Kn is, let's see, -1 minus -3 squared plus 1 minus -2. So 1 minus -2. Square it. So let's see, it's going to be 2 squared plus 3 squared, which is 4 plus 9, which is a square root of 13. So if I punch that in, I get 3.60. And then I double that because I have 2 of them that are that long. So I get 15.81 plus 10 is approximately 25.81. Now, if you go look this up in the book and it's a little bit different, keep in mind, and this will happen on quizzes and tests too, if you round off too many digits, it'll change your answer. So in that calculator, I didn't clear that. So my answer might be slightly different than the books. Again, you can watch the videos on 4 and 6 if you choose to. I'm going to go ahead and move forward there. Now, area is a little bit different. Area, you're going to need the formula. Especially with triangles, pay attention to what your picture looks like, because area, you might not have to do the distance formula at all. So if I plot this, D is at 1, 3. E is at 4, -3. So we're here. And then F is at -4, comma -3. So -4, -3 right there. If I look at this, sometimes kids start doing the distance formula for these sides like DE and DF to find the height. But remember, the area formula of a triangle is 1/2 base times height. So I need to identify a base, which I'm going to call the base FE. And I can count what FE is because both of my Y values are the same. So FE is equal to 8. And then for my height, it's from the vertice that's not on my base straight down to it. So I need to look at the Y values from D to the Y values on F, because that's my base, is 6 units. So my height D to line FE, my height D to line FE is 6. So I'm just going to plug that in. 1/2 times 8 times 6. So I get 4 times 6, which is 24 units squared. Okay, so again, plot them. It helps. There's graph paper available. Again, just for the sake of time, I'm just going to do a couple of these. So I'm just going to do 7 and 9. Okay, I'm not real sure what they're going to look like, but those are the ones I'm going to do real quick. So 7 is 2, 2 for G, 3, -1 for H, and -2, -1 for J. So if I again look at this and plot it, I can use JH for my base. So from J to H is 5 units. And then G to JH is 2 units. So G to JH is 2. So if I say 1/2 times 2 times 5 or 5 times 2, it doesn't really matter. If I cancel those out, it's just 5 units squared. Okay, number 9, -2, 3 is F. 1, 3 is G. 1, -1 is H. And -2, -1 is J. So again, area formula for a rectangle is a little bit different. It's just simply length times width. So I need to find a length and I need to find a width. This one's really nice and easy. I can just count. So 1, 2, 3, 4 for the length times 1, 2, 3 for the width. And that equals 12. Keep in mind, if you have a polygon in here and it for some reason ends up diagonal, you may have to do the distance formula for part of it, but most of the time, some of them are the same size. So you can just double it, and you might have to run the distance formula once or twice. Okay, and again, the last thing, just modeling with mathematics. You're building a fence in your backyard, or a shed in your backyard, excuse me. The diagram shows the vertices of the shed. Each unit in the coordinate plane represents 1 foot. So what we'll do is when we're doing this problem, we have to find the area or the perimeter or whatever the case may be. Keep in mind with these story problems, you guys, you're just going to do the same thing you're doing in the homework. So if it's asking for the area, you're going to do length times width, and remember it's feet squared. If you're going to do the perimeter, you're going to add up all the sides, and it's just simply feet, okay? So again, for the sake of keeping it short, that's kind of how you would do one like that. This one's asking for the area, so you would multiply length times width, and I have 5. Well, let's change that color so we can see it a little better. I have 5 times the width, looks like it's 6, so it looks like it's going to be 30 square feet. Okay, so in summary, again, ideally we were able to find the perimeter and area in the coordinate plane. We did several examples. The other thing that was a key from this section is make sure you can classify those polygons like we talked about at the beginning of the video. Thanks.